Good afternoon to the professors. Myself, Bodev Sahu. I want to present my recently accepted paper in ODCON 2021. This technical conference is co-sponsored by IEEE and the section which belongs to IEEE Kolkata section and IEEE Bhubaneswar subsection. The topic title is Advanced Control Technique Based Neutral Clamped Inverter Operation. The paper ID is 64. To accomplish my topic title, the study contains objective, introduction, neutral clamped multi-level inverter operation, advanced control design, system results, harmonic analysis, comparative study, conclusion, future study, and references. Before we are going to the subject, the objective of the study is listed below. And then first point, looking at the real-time application, first major objective of the paper is to improve the power quality of the renewable energy based microgrid system. Due to the dynamic behavior of solar PV, the power quality problem becomes a challenging issue nowadays. Then second point, to achieve multi-level voltage and current operations, second major objective of the develop an appropriate neutral clamped multi-level inverter. Further, to improve the stability and multi-level inverter performances, the third major objective of the paper is to regulate the DC-link voltage of the multi-level inverter at its desired or reference value and compute the reduced current error through an advanced control strategy. As per the planning, the appropriate design of neutral clamped multi-level inverter and MLMS based controller not only enhances the power quality and stability but also decreases the size, cost and complexity of the system. Then in introduction section, then initially we do some literature survey. First point belongs to, due to the excess power demand and environmental problems occurred by the traditional power plant, renewable energy source based energy generating units such as solar and wind systems are gaining popularity. Among all the distributed generations, solar-based generating stations provide most attractive features like easier integration, reduced cost and availability. However, the extraction of the maximum power and optimum voltage is a challenging task due to the environmental uncertainty condition. Therefore, looking at the required condition, it is essential to find the best solution for computing the optimum power from the renewable energy source based system. Second point, previously we are focusing about two-way conversion, like we are using a boost converter to boost the solar system, and after that we are converting through the a inverter. But however, during the two-way conversion system we are requiring a larger system and the cost of the system is high. Therefore, to reduce the cost and size, we are specifically choosing the multi-level inverter for single way solutions. Therefore, there is a necessity to appropriate design of inverter is required for the operations. Then in the control, not only the inverter design is a major concern, but there is also a major concern is controller. Then after doing some literature survey in paper number 13, we found that a repetitive controller is suggested for to compensate for the system harmonic. However, during the perturbation of the controller, the model system takes a lot of time and to compensate the harmonic. In 14, a robust control based approach is used to model a similar type of system. However, in this approach, the system is designed without using RES based system. In 15, mathematical morphology and instantaneous theory based controller is developed for a larger power application. However, during the design and integration, we are facing some major challenges like additional computational burden and system complexity is occurred. In 16 to 18, a PI control based multi-level inverter is used to solve the PQ problem. However, during the design, it requires an excessive number of switches by which the system also injects excess harmonics. Therefore, there is necessity of a advanced controller for the inverter operation. To circumvent the above problems, the major contribution of the study is RES-based generating system is integrated for MLI operation. IC-based MPP technique is used to extract optimum power. 3-level NCI based MLI is proposed to facilitate single-way solution, and ACT technique is proposed to improve the stability and power quality of the system. This is my complete system model where a PV is integrated to the grid by using a 3-phase level inverter and LCL filter. The 3-phase 3-level inverter contains all around 12 switches like 12 IGBTs and 6 diodes. Then the operation. This is the single leg conversion, where we are generally using the 4 switches, and the 4 switches, one is your upper is positive, the lower is negative, and medium is neutral point. Then during the positive half cycle or positive voltage, the upper 2 switches NR1 and NR2 are operated, and it gives the positive voltage, and the negative half cycle, the NR3 and NR4 is operated, which gives negative half cycle, and the zero sequence voltage, zero voltage or neutral current. During the neutral current operation, there is a 2 NR2 and NR3 operations are occurred. During the operation of NR2 and NR3, there is the inverter faces some losses, and this is the SPPWM we are using. We are showing here the SPPWM technique for the switching signal generation, and this is the MPPT tracking algorithm we are using. And by initially the voltage of PV and current wave sensing, and the memory block is present there, and this by using this formula, this is the duty ratio formula, 1 minus BS star means the reference voltage and the actual voltage of the solar. By using this formula, we are computing the duty ratio, and by using the maximum power V reference and ISA, we are computed the maximum power. Taking the derivative of the maximum power with respect to voltage, we are computed the conditions for the maximum power point operation. We are generally using the incremental conductance method. This is the total phase component extraction formulas are there. Estimation of real power magnitude, the formulas are there. This is the estimation of real power magnitude. This is generated by controlling the DC link voltage, and the reference current extraction process is occurred by properly computing the weights of the respective current extraction techniques. And this is our proposed technique, by which proposed controller or complete control cycle, by which we are able to compute the accurate error current signals. And here the advanced control technique is here. By using these formulas, we have computed the appropriate weight of the grid current or grid current, respective grid current for different phases. And by using DC link voltage controller, we are controlling the DC link voltage. And by using the incremental conductance method, by using by sensing the appropriate solar voltage and solar current, we are calculating the appropriate weight of the solar, and adding the DC link voltage and appropriate weights of the reference phases, and we are generating the actual weight by multiplying the reference current signals are calculated. Then this is the output response of my solar PV, and by varying the irradiance, the solar voltage is also varied, and appropriately by using the control technique, maximum power point tracking technique, it offers maximum solar voltage and solar current, by which we are obtaining the maximum power by using this method. And this is the diode current, by which solar diode current, solar is operated like this, and it is also estimate the maximum current. And the grid power is like this. By properly computing the solar voltage, the grid power is also computed. And this is my comparative study. By using the traditional inverter operation, the grid current contains higher harmonics, that is 3.56% current and 1.5% voltage. By using my proposed topology, the inverter can generate multi-level inverter, and this is my reference voltages, VDC reference voltages, and the output current is reduced to 0.06%, and this is very high, lesser value for the operation. And comparative results shows my total percentage of improvement is 97.83%. The conclusion, and in the analysis section, we are showing that appropriate improvement percentage is 97%. And the conclusion, the proposed ACT-based NCI is successfully used for solar microgrid operation. NCI inverter generate multi-level inverter operation, and generate 3-level inverter operation, by which you are getting lesser voltage error. And the obtained and analyzed system results serve as a basis for the designing an appropriate system design and control for real-time applications. The future scope is with the developed model and inverter and control model is applicable for unbalanced and nonlinear load application. Reduced switch cascaded H-bridge multi-level inverter also is used integrated for the real-time application. It is also applicable for microgrid and hybrid microgrid system. And then this is fuzzy NN and repetitive control is also used for improve the stability. And this is my references, and thank you.